solids, right? So what is happening in diamond? In diamond, you can see these molecules: blue, 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 red, red, red balls, blue, blue, blue. All these are arranged in systematic fashion, right? As I go from left to right, I see here 5 blue balls are there. As I go like this diagonally, I can see here blue, red, like that. As I go like this, blue, red, blue, red, blue, red. So there is a systematic arrangement of molecules when it comes to this diamond, right? But if you see a glass, the arrangement is not so systematic. Okay, so you can see that there is disordered arrangement, right? Now, disordered arrangement, what does it conclude to? What kind of solid it is? We'll come to that in the next slide or next animation. So, diamond and glass, you see, diamond has a more regular arrangement. Glass has got a less, we can say less regular arrangement, right? So, what does it conclude? We'll come to that. So, the particles in diamond is regular arrangement, you can see here, and then the particles in the glass, they are disorganized, right? Disorganized means suppose you are staying in a room, okay, especially boys also, you are staying, boys are comparatively known to not keep your things in order, right? Not all boys, most of them, right? Girls, they keep things in a systematic fashion. So, in the same way, there is arrangement, regular arrangement, there is irregular arrangement. Now, this brings about some difference in the properties, right? So, what is the difference in properties? Now, when there is a regular arrangement, we call such solids as crystalline, right? And where is disorderly arrangement, we call such solids as what? Amorphous, right? So, disordered arrangement like glass, plastic, we say amorphous. When it comes to crystalline, like NaCl and all, we consider, okay, diamond, we consider them as crystalline solids, right? So, crystalline solids का properties क्या है? क्योंकि इसमें arrangement of atoms regularly है. I don't want to repeat it. And since arrangement is regular, it has got a long range order. That means they are regularly arranged to a greater extent. Okay, the arrangement of molecules are regular to a greater extent, right? Blue, 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 blue. It's coming regularly, 5 blues together, right? But in amorphous, what you see? After blue comes red, and after red comes blue, again blue, 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 like that, right? So this has got a long range order. Their definite pattern is there up to a large interval, right? So we call such solids, crystalline solids, as having possessed what order? Long range order, right? And then if I go to the next one, yeah. So more or less the arrangement of molecules are the same. Okay, if you take this section or if you take that section, right? Arrangement of the molecules, there is some regular pattern in arrangement, right? So examples of crystalline are NaCl, okay, diamond, right? You have seen some examples. Let us go through that. NaCl, diamond, solid iodine, you can see on the board, gold, right, and then quartz. These are examples you should keep in mind, right? Then amorphous solids, non-regular arrangement, okay, and you can see that some places there are orderly arrangement, like here on the red zones they are orderly arrangement, but more or less they are not having regular arrangement, so they are said to possess short range order, okay. Now, let us come to some other properties of the amorphous solids का examples क्या है? Glass है एक example amorphous solid का. Next example, you can go to the next example. What is the next example? Rubber, and the next example is plastic, right? Then amorphous solid का एक और property देख लो आप लोग. जो भी building देख लो, जो भी glass panes आप लोगों के घर में है, you find that the glass panes, the glasses are thicker at the bottom, right, compared to the top. As you come from top to bottom, the bottom layer of the glass is thick. There is some scientific reason for that. Okay, the scientific reason you can see here. The scientific reason for that is simple, right? You can see here. The scientific reason is because of gravity, right? As this amorphous solid, glass is a amorphous solid, as it melts due to gravity, it comes piles and piles up. Okay, molecules they start flowing from top to bottom, and as a result, the bottom part they have got thicker. Okay, thicker mode is present in the bottom part, and that takes a lot of years. Right, this process is very slow. Okay, so due to this ability of amorphous solids to flow like liquids, they are called the super cool liquids or pseudo liquids, pseudo solids. Right. So in exam, they may ask you a question: what is the difference? What do you mean by pseudo solid, or what do you mean by super cool solid? The answer is simple. The answer is your amorphous solid. Right. And then let's move on to the next points of differences. The next points of differences, let's come to that. Okay, points of difference. Right? The first one is melting point. Right? The melting point. In crystalline solid, they have got sharp melting point. Okay, but because of the regular arrangement. But in case of amorphous solid, the melting point is not sharp. The melting point varies. Okay, some portions. You will see that some portions the melting point is different. Some portions they have different melting points, right? Because of that, they have some range of melting points, right? Some portion the melting point is high, whereas some portion the melting point is less. You can see here the melting point is less because this is not so orderly arrangement. Okay, here the melting point is more. Okay, more systematic, more dense. Populated molecules, right? So you can understand this way. Okay, and a few more differences are there. Like for example, when you have a crystalline solid, when you cut a crystalline solid, it produces a regular shape. So when you cut a amorphous solid, they don't give you the regular shape. So for that reason, when you try to cut a glass, it's always advisable that you take a cloth in your hand and you try to cut that glass. Otherwise, you hand will bleed on it, right? Because of the irregular shape that is being there, right? And one more property is that crystalline solids are anisotropic. Okay, what do you mean by anisotropic? Anisotropic is a property that these crystalline solids they show different physical properties in different directions. Okay, the different physical properties like your refractive index and your electrical resistance. Okay, so all these properties will be different when you measure it in different directions. That is called the property of anisotropy. But in case of amorphous solid, because of the irregular arrangement, they don't show anisotropy, they show isotropic nature because the properties like electrical resistance, refractive index, etc. will be same when measured in all directions. So that is also one important difference between amorphous and crystalline solid. Right? So I hope you understood whatever I have taught today in this lecture. In this lecture, we have studied about the solid state introduction. We have studied about the different kind of parameters that makes a solid, a liquid, and a gas. We have also studied about the types of solids, which are mostly crystalline and amorphous. I hope you liked that video, and please subscribe to my channel, and may God bless you all, and have a nice day all of you.